Hello students, welcome back to our digital version of Hands-on-Math for Journey's spring semester. Last week, as you remember, we focused on lines. So we discussed the different types of lines, which included a line, which remember goes on forever and has arrows on both sides of the line. That's how we note a line. And then we have a line segment. So that can be from has a starting point and an end point. It's a segment of a line. We can measure it. And then lastly, we have a ray, like a ray of sunshine. It has a starting point. It does not have an ending point. It goes on forever. So to kind of expand on lines, today we will be talking about angles and triangles, okay? So some of the things that we can make with lines are triangles and angles. So there are 6 different types of angles that we're going to talk about today. And 2 of those have the word line in them. But we have something called an intersecting line. Okay, so intersecting lines. And if you notice, each of these sections here, it's broken into 4 sections where the lines intersect. They have angles there that we can classify, which we'll talk about at another session. But these are what you call intersecting lines, okay? It's 2 lines that cross anywhere on either of the lines, okay? And then a more specific type of intersecting line looks like this, okay? And these lines are called perpendicular. Perpendicular, okay? So perpendicular lines cross each other and make right angles on all 4 of those quadrants like we talked about, okay? So right angles. And you may be saying, well, what's a right angle? We'll get to that, okay? So intersecting lines intersect each other anywhere, anyhow, but they just can't make right angles. Whereas a perpendicular lines are 2 lines that cross that create right angles on all 4 sides of that quadrant, okay? And now, what is the definition of a right angle? Well, if it's not a right angle, it's a wrong angle. Right angles are my favorite. So a right angle, think about an L, okay? So a right angle are where 2 lines meet at what we call a 90-degree angle, okay? So they have to meet at 90-degree angles, which is one going straight up and down and one going back and forth, both straight and level, okay? And so right angle is defined as 2 lines intersecting at 90 degrees. And we're going to talk about degrees soon. We're actually going to work with a protractor today. So get your protractors out. All right, so this is a right angle. Now, and I remember I talked about 90 degrees. So an angle that is less than 90 degrees, we call an acute angle. So I should probably label these. So this is right, this is acute. So you see it's smaller, okay? It's not as large in its opening. And then the next type of angle that we're going to talk about is obtuse. And an obtuse angle is larger than 90 degrees, okay? So you can see right angle, back and forth, straight up and down, 90 degrees. Acute, smaller than 90 degrees, less than 90 degrees. So it's from 1 to 89 degrees. And obtuse is larger than 90 degrees. So it's 91 degrees to 179 degrees, okay? Now, here's the way I remember these. You ready? Acute angle. It's so acute. It's so small and acute, okay? So things, when we see little tiny things, lots of times we say, oh, it's so cute and little. And then obtuse angles, the way that I like to remember obtuse angles is when something is big, we can call it obese, right? So obtuse angle, it's obtuse, it's really big. Okay, so it's bigger than right. So right angle is kind of like our measuring point. It's our center point. If it's smaller, it's so cute. It's an acute angle. If it's larger, it's obtuse. It's big. It's an obtuse angle, okay? Now there's one other kind of angle, and this one's probably the most confusing, but We have one called a straight angle. Okay, so this is called a straight angle. And a straight angle looks just like a line, right? And its measure is 180 degrees. Now, where am I getting all these degree things from? Let's try to explain this. We're going to move over here a little bit. So when I'm staring, have you ever done this exercise where if I'm staring straight at you, this is my starting point, and then has anyone ever told you to turn around 360 degrees? So you go like this. Okay? When we talk about circles, the measure from start to stop is 360 degrees. Okay? So 360 degrees. If we were to break this into 4 parts, and we went from our starting point here to there, do you see how this makes a 90, what I've been telling you is a 90-degree angle? There's a glare on that. Let me see if I can shield it so you can see. Hold on, let me erase the board and try this again. We're gonna erase the right angle because I see there's a glare from a light there. Okay, so here's our circle. It's not a perfect circle. Okay, but if you start here and you go this direction and you go a quarter of the way around, you can see that it forms a 90-degree angle. So if I'm staring straight at you and I want to turn 90 degrees, where am I going to go? I'm just going to go like this, right? Okay, and then if I go 90 more degrees, what's 90 plus 90? That's right, 180, okay? So if I start here and someone says turn around 180 degrees, I'm going to be with my back to you then, okay? And then if I go 90 more degrees, or one more of these quadrants, what's 90 times 3? Well, 9 times 3 is 27, add a 0, 270 degrees. And then if I go another quadrant, or 90 degrees, what's 90 degrees times 4? Well, 9 times 4 is 36. 36, add a 0 is 360 degrees. So 0, 90, 180, 270, 360. Okay, so now let's go back to these angles. So we have our right angle, we've talked quite a bit about, right? So that's a quarter of a full turn. A straight angle, can you see why this would be 180 degrees now? As we talked about our circle and the quadrants, if you start at one side and go all the way around, it's 180 degrees, or half of 360, right? And then an acute angle goes from 1 to 89 degrees, okay? So that still works, and obtuse is larger than 90 degrees, but smaller than 180 degrees. All right, so these are the types of angles. So we've discussed, here's our worksheet, kind of like what we did last week with the lines. We have perpendicular lines, right, which are 4 90-degree angles. Intersecting lines cross each other, but not necessarily at 90 degrees. We have right angles, and we have acute angles less than 90 degrees. This is a straight angle, 180 degrees. And our obtuse angle is from 91 to 179 degrees. So in your inbox and on Edmodo will be this worksheet. You can print it out. If you have toothpicks, go ahead and use those. If you don't, you can use markers, crayons. You can even get creative and maybe use yarn or something fun. Have some fun with it, because I know you've got time on your hands. So have a little bit of fun learning about angles, okay? So those are our angles. And then we are going to also, as I said, be talking about triangles today. So let me check my notes. Oh, there's one more thing I wanted to show you about angles. There's a little trick that we can do using our hands, okay? I'll use this hand. So if you look at your fingers, okay, from your thumb to your pinky is about a 90-degree angle, okay? And then from your thumb to your, I guess your pointer finger This is about 45 degrees or half of a 90-degree angle, okay? So when we look at our hands like this, sometimes we can remember that from our thumb to our pinky, when we stretch our thumb out, is 90 degrees, okay, if we're going to estimate. And then from our thumb to our pointer finger is about 45 degrees, which is half of a 90-degree angle. If you take 90 and divide it by 2, you get 45. All right, so next we're going to be talking about triangles. There are 3 types of triangles, and we define when we talk about angles and triangles, okay? There are 3 types of triangles. We have an acute triangle. So now remember, acute means what? Less than, oopsie, 90 degrees, okay? So that means if you have an acute triangle, it means you have a triangle that all the sides are less than 90 degrees. Now, sometimes that can be a little hard to draw, so let me try to do that. I always get what looks like a 90-degree angle. Nope, that's not going to work either. Let me look at my notes. All right. There we go. 3rd time's the charm. All right, so an acute triangle has 3 angles in the triangle that are all less than 90 degrees, okay? A right triangle is just a right angle, and you see I always draw this little box here, okay? Remember that a square has 4 equal sides and 4 equal angles, so we use this symbol consistently through mathematics to note a 90-degree angle. But when we take those 2 lines that make up the angle and we draw a 3rd one, we now have a what? A triangle. Did you notice in the word triangle has that prefix tri? Tri means 3. Think about like a tripod that holds a camera. It has 3 legs. Or a tricycle has 3 wheels, okay? That prefix tri is always going to mean 3. So triangle, 3 angles. We have 1, 2, 3 angles. So this is a right triangle, and that means that one of the angles is right, or 90 degrees. And then the 3rd type of triangle, now if you've been paying attention, we have acute, we have right. What do you think the 3rd kind of triangle is going to be? That's right, obtuse. All right, so it's going to have one angle that's larger than 90 degrees, and it's going to have 3 connected lines. Okay, so this is what we call an obtuse triangle. All right, so these are the classifications of your 3 types of triangle by angle. So if you see on a standardized test, which congratulations, you won't have this year because of the coronavirus. They've canceled those. So let's just clap for that. No one likes those standardized tests. But if you were asked what to classify a triangle by its angles, the right answer would be either acute, right, or obtuse. Review. Acute has 3 angles that are less than 90 degrees. Right has 1 angle that is 90 degrees, and obtuse has 1 angle that is greater than 90 degrees. All right? Now, if that wasn't enough about triangles, we can also classify triangles, by the lengths of their sides, okay? By the lengths of their sides. And there are 3 types of triangles by their sides. The 3 are equilateral, isosceles, and scalene. Okay, so those are the 3 names: equilateral, isosceles, and scalene. All right, so what do those things mean? Equilateral, do you see the word equa in there? Equal? Equal usually means the same, right? 2 plus 2 equals 4. If you have 2 of something and 2 of something and 4 of something, you have an equal amount. So an equilateral triangle is a triangle that has 3 equal sides. Now I'm drawing on the board, so I can't measure it out perfectly, but I'll show you my worksheet in a minute. And I did measure it, so it's close to perfect, but probably not perfect, but close. An isosceles triangle has 2 sides that are equal and 1 side that isn't. And so a lot of times we see a shape like this, okay? And then the last one, scalene. So if we have all the same, 2 the same, what do you think scalene is going to be? None the same, okay? So a scalene triangle might look something like this. All right? Now, when we talk about the sides of triangles, there's a way that mathematicians and a way that you're going to note the length of the side for a triangle. All right? And that's with these little tick marks. Now, if you notice, I've just used 1 tick mark on each side. That lets us know that all of these sides are the same length. Now, when I go to my isosceles, I'm going to use 1 tick mark on the sides that are the same and 1 on the one that's different, which tells us that these 2 sides are the same measurement or the same length, and this one is different. Okay, so this one has all the same. This one has 2. What do you think this one's going to have? 3 different tick marks, right? Because it has 3 different measurements of sides. So I have 1 there, 2 here, and 3 there, okay? So equilateral, isosceles, and scalene. Now, I tell you guys all the time, to be honest with you, growing up, I had a really hard time with things like this. I was not good at memorizing vocabulary words. So if somebody asked me what equilateral triangle was, I probably couldn't tell them because no one explained to me some of the little tricks that I try to explain to you guys. So equilateral is probably the easiest because it has the word equal in it. And so by knowing that it has the word equal in it, we can remember equal sides. Oh, okay, equilateral, equal sides. 3 equal sides. But then you've got these 2 crazy words, isosceles and scalene, okay? And so here is how I like to remember these. You ready? For equilateral, besides the fact that it has equal in it, is it true that usually the 3 legs that come off the back of the E are the same length? It is, okay? So 3 equal sides. Now isosceles, when we take that I and we draw it out, is it true that the top and bottom parts of the I and the up and down part of the I are different? Okay, so these 2, the top and bottom, are equal in length, and the middle one's usually longer. So that's another way that we can remember that an isosceles triangle has 2 sides that are the same measurement and 1 side that's not. Top and bottom of an I are the same length. The up and down portion of the I is a different length. And then with a scalene, how many sides are equal in an S? 0, right? It doesn't have any sides. It's a curve, right? So we can remember 3 equal sides with the legs that come off the E, 2 equal sides on the top and bottom and 1 that's different going up and down, and no equal sides. Okay? Hopefully that helps. Now, if that wasn't enough, I have 1 more, okay? You ready for this? And I've never done this on camera before, so please don't use this to blackmail me later. But there's a little song you can sing too that will help you. It goes like this. Isosceles, isosceles, you look just like a Christmas tree. Okay? So if you can remember isosceles, isosceles, you look just like a Christmas tree. If you can remember that and draw what a Christmas tree generally looks like, you might be able to remember that an isosceles triangle has 2 equal sides and the 3rd side is a different length, okay? That was a lot about triangles, wasn't it? Did you know there's a whole study in mathematics on triangles called trigonometry, that if you get into really high level math in high school, and if you decide to go into mathematics in college, you will study trigonometry. You can do a whole year study of just learning the properties and math of triangles. I didn't ever do that, but they're kind of fascinating, which is why I wanted to teach you about them. And knowing these vocabulary words will really, 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 really help you as you move on into pre-algebra, algebra, and geometry, okay? Remember this, when we study shapes, we call it geometry, and then this would also be known as trigonometry, which is inside geometry. All right, now, I'm going to post a worksheet for you, send out a worksheet for you so you can go back through and watch this video and you can classify your triangles. Now you'll see I have types of triangles by angle. So the 3 angles, right, were acute triangle, which has 3 angles less than 90 degrees. Right triangle, remember, if it's not a right triangle, it's a wrong triangle. And the right triangle has 1 measure that's 90 degrees. And then you have your obtuse triangle, okay? So your obtuse triangle, remember, it's obtuse, it's big. So it has 1 angle that is larger than 90 degrees. And then we can classify triangles by side or length, okay? And so if all 3 sides are the same, we call it equilateral. It gets 1 tick mark on each. Isosceles is 2 sides the same, 1 side different. 1 tick mark on 2, 2 tick marks on the 3rd one. And then scalene, no sides equal. So 1 tick mark, 2 tick marks, 3 tick marks, all right? So these worksheets, both the triangles and angles worksheets, will be in your inbox and on edmodo.com for you. And you can print them out, go back through the video, label your worksheets, get creative if you don't have the toothpick, sorry, the word almost escaped me. And then, like we did last week, what I'm gonna do is give you time to fill out your worksheets, and then if you send me pictures of those or upload them to Edmodo, you will get, I'm keeping track of what you're doing, and you will get a prize when we're meeting back together. Hopefully, I'm hoping that we will be back together by the beginning of May, hopefully the end of April. But we want to obey the authorities, and so we will do our best to continue to learn math in this format. And so I will post everything for you, and then like I said, like last week, I will post some extra worksheets for you about triangles and angles, and I will post a quiz on Edmodo that you can take to help refresh your memory and help to really reinforce these new vocabulary words. So the new words we had today were acute, right, obtuse, equilateral, isosceles, scalene, and then we had perpendicular, intersecting, and a straight angle. Remember, a straight angle is just like a line, but it can also be considered an angle because it's 180 degrees. We'll review that. 0, 90, 180, 270, 360. Now, I did say that we were going to get to working with protractors, which shows us how to measure angles, but I think we're going to keep that to next week because this was a lot for today. And so next week we'll be doing a little craft with our names and measuring angles, and that'll help to reinforce what we learned today, and then we'll introduce some other new concepts. So I hope you had fun. I hope you guys are doing well. Get out, take a walk if you're allowed to, and I will see you next week.